All right, hello everyone. Welcome to my channel. What's going on out there? This is an educational channel. Try to give you some learning about important topics, important to me, inspiring topics, topics that could enrich your life if you learned about them, particularly theories of everything, paradigm shifters, all-encompassing theories, magnum opuses from obscure authors who spent their whole life working on something and never got any credit for it. And today is our 389th video that we've done on the reciprocal system of theory, which was originated by Dewey B. Larson back in the 20th century. In 1959, Mr. Larson wrote up his two fundamental postulates, basically two sentences that described how the universe operated. And then over the next 30 years of his life, the final 30 years of his life, he took those two postulates through a process of deduction in order to arrive at a theoretical universe. So if my postulates are correct, this is what the universe would look like. I went over those in about 15 videos that I did about a year ago called The Outline of the Deductive Development of the Reciprocal System. And then in his books, Mr. Larson compared and contrasted how his theoretical universe appears next to the measured and compiled, observed universe of the legacy scientists. And it is very interesting. Larson was really able to almost reproduce a lot of the scientific tables just from theory. And so you think that he might be onto something. But no, the scientists just ignored him and shunned him and hoped he went away. Well, I don't think he's going away. I mean, Larson passed away in 1990, but his theory lives on. It's fledgling. Not so many people involved, but there have been a handful of people who've come to the fore and have made great contributions. And I don't pretend to understand the theory probably well enough to make a major contribution, but I can at least put my 2 cents in and try to get it out there to other people. I figure even if I just get it out there to a few people, it could lead to something. And I do honestly believe that the reciprocal system will be the fundamental science, not only science, but all subjects for curriculum in every subject. This is what we will be using either later here in the 21st century or in the 22nd century. Eventually, we will figure it out, and the reciprocal system will be the foundation upon which we found all our subjects. All our subjects are going to be based on the reciprocal system. So we might as well get busy learning it now, so that we'll be ahead of schedule. They'll try to suppress it for who knows how long. They'll get away with it, but eventually the truth always comes to the top, just like a beach ball. You can You can try to hold a beach ball underwater, but eventually it pops out. And, you know, I'm not saying that Larson has everything right, but he has the kernel of it. And he has given an example for how to get the rest of it. Now, the basic idea, just to maybe iterate Larson's two postulates. The first postulate is the main one. The second postulate is just, you know, kind of a formality for the purposes of math and geometry. The first postulate more or less reads, the universe is composed of only one entity, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. And then the second postulate is that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Now, going back to the first postulate, if I were to rephrase it, I would just say, you know, the universe is not made out of matter. It's not made out of energy. And it's not made out of one of the fundamental forces, or all of the fundamental forces. It is made out of motion, particularly scalar motion, which is a motion that has a magnitude but has no specific direction, a non-localized kind of motion. And motion is the relationship between space and time. Motion is basically a fraction with space or time as the numerator and time or space as the denominator. All of our scientific quantities are ultimately motions, including matter, energy, and force. And they are all just different kinds of motion, along with everything else, pressure and temperature and electric charge, electric current, magnetic flux, surface tension, viscosity, density. All of these things are relationships between space and time. Space and time, being reciprocals of one another, are identical, except that they are reciprocals of one another. They do not exist in and of themselves. They only exist together in motion. And whatever quality one has, the other also has. The primary qualities that they have are their scalar aspects, which is what Larson calls clock time and clock space. The best way to envision the scalar motion is using a balloon with dots on it. Maybe not the best, but a way. If you blow up the balloon, all the dots are moving away from each other, but they're not moving in any specific direction. That is a scalar motion. They don't get any type of direction until you decide that arbitrarily that one of the points is motionless, and then you can set it up, set up a system of directions based on the fiction that one of them is motionless, but they all are in motion away from each other. And clock time is also is always getting later and later and later, but it's not moving in any specific direction. So space is getting farther and farther and farther apart. Time is getting later and later and later. Clock time and clock space. But then there is also coordinate time and coordinate space. This is more of a fiction. If you decide to slow down and stop the universe, then you can see time and space in three dimensions, three stationary dimensions, the way we see space, x, y, z coordinates, or volume, three dimensions of stationary space. And under certain circumstances, you can also see the universe as three dimensions of stationary time. And time and space are both quantized. They both come in discrete units only. So there is a minimum unit of space and a minimum unit of time. You have to have a full unit before you have that entity at all. And if you have exactly 1 unit of space in 1 unit of time, you have the speed of light. And the speed of light is what Larson calls unit speed. 1 over 1 equals 1. And unit speed is the background motion of the reciprocal system universe, or the universe of motion. So in a universe of motion, where motion, everything is made out of motion, if you have a universe of nothingness, you still have motion. And what you have is you have a scalar motion outward in all directions at the speed of light. That is what Larson calls unit speed, but the 0 point, or the reference point, the progression of the natural reference system, the null point, the neutral point. So that is what you have. And therefore you have half of the universe that is actually moving faster than the speed of light, which flies in the face of the legacy scientists like Einstein, who say that the speed of light is the maximum speed of the universe. In Larson's system, it is the midpoint of the universe. Half of the universe moving slower, half moving faster. That Larson calls the material sector and the cosmic sector, respectively. And you can see the reciprocal relationship in the material sector. You have 3 dimensions of stationary space, coordinate space. And you have clock time. The clock is always getting later and later and later. This is our familiar reality. But in the cosmic sector, we go over to a reciprocal reality where we have 3 dimensions of stationary time, and we have clock space. Space is always getting farther and farther and farther apart. So we have the same relations, but they are the roles of space and time are reversed between the material and cosmic sectors. So that's just a short outline of how the system works. Now, we may be able to get into a little bit more here as we proceed on with reading Larson's paper that he gave back in 1979 at a conference, and the paper is called Science Without Apologies. And this is our 3rd installment of this. So if you want to start from the top, you want to go back 2 videos and start from the top. Now, in the first installment, he was basically showing how the legacy scientists don't really know what they're talking about. And they are clamoring for a generalized theory that puts the hodgepodge of all the different disparate theories that the scientific establishment has come up with, a different theory for every subject. They're clamoring for a generalized theory. But then when one shows up right in their wheelhouse with Larson, they reject it because it would require for them to adjust their paradigms more than they're comfortable with. And then in the second installment, he goes over a little bit of what his so he's basically saying in the first segment that the scientists are always giving apologies for not having not really knowing what's going on, what they're talking about, not having a generalized theory, not being able to answer all the questions. And then in the second installment, he goes over his reciprocal system a little bit, talks a lot about scalar motion and about the expanding balloon, and what kind of a motion that is, and it's different than a velocity. Most people, when they think about motion, are thinking about velocity, which is a motion with a direction. But this is a more fundamental, generalized kind of motion, a scalar motion that has a magnitude but has no specific direction. Okay, so now we're going to get started with the third. I think I'll go back one paragraph just to provide a little bit of continuity, although that paragraph's pretty long. It starts with a quote from Einstein. Now, I'm going to go a little further than that. Okay, Einstein's conclusion that there is no way out of the difficulty but to assume an answer and take its validity for granted is simply another kind of apology. One of the reasons why those who are in any way connected with science ought to hope that the reciprocal system is a correct account of the physical universe is that it solves such problems rather than sweeping them under the rug as Einstein has done with the radiation problem. The photon of radiation is an object that has no capability of independent motion, no mechanism whereby it can alter its position. In a universe of motion, it therefore stays put in its original location and is carried outward at the speed of light by the motion or progression of the natural reference system. This is all there is to it. We do not have to dream up any complicated mechanism or make a guess and take it for granted. But this is not the whole story. One of the most significant features of a general physical theory is that the same principles apply in all physical fields. We do not have to develop new laws and new principles in every new field that we enter. The same general principle that applies to the motion of the photons of radiation, the progression of the natural reference system that causes them to move outward at the speed of light, applies with equal force to all other objects in a universe of motion. All physical objects move outward at the speed of light. However, this is not necessarily the only motion of such objects, as it is in the case of the photons. Most other objects are subject to additional motions, and the actual change of position in a stationary reference system is the net resultant of all of the motions of an object. The most important of these other motions is gravitation, which moves all material objects inward toward each other, thus acting in opposition to the outward motion of the natural reference system. So you can think about sucking in the balloon. All of the dots are moving toward each other. In our local environment, the inward motion due to gravitation is so much greater than the outward motion that the outward motion is negligible. And gravitation appears to be the only general motion of material objects. But gravitation is attenuated by distance, and at some distant location, the gravitational effect on any material aggregate is reduced to equality with the constant outward motion. According to the theory, beyond this point, the net motion is outward, increasing toward the speed of light at the extreme distances. On this basis, therefore, all aggregates at extreme distances where the effect of gravitation has been reduced to a negligible level should theoretically be receding at the full speed of light in the same manner as the photons of radiation. Astronomical observations indicate that this is just what is happening in the case of the distant galaxies. All aggregates of matter other than the very largest, the galaxies, are under some degree of gravitational control by larger aggregates, and their outward motion is limited. But the galaxies behave in exactly the manner required by the theory. The nearby galaxies have very little motion one way or the other, but all of the very distant galaxies are found to be moving radially outward at very high speeds, increasing with the distance and reaching a substantial fraction of the speed of light at the present observational limit. Current astronomical thought attributes the high recession speeds to a gigantic explosion at some singular point in the past history of the universe, which threw all of the contents of the universe out into space at enormous speeds now observed. In spite of the purely ad hoc and rather fantastic character, this Big Bang theory has gained widespread support, mainly because there has heretofore been no more satisfactory alternative. But its lack of validity is easily demonstrated if we examine the motions of some of the smaller aggregates, because we find that these too have outward motion components, motions that are impossible to explain on the basis of the Big Bang hypothesis. The globular star clusters provide a good example. These are immense, nearly spherical aggregates containing anywhere from 100,000 to more than 1 million stars, separated by enormous distances, not much less on the average than those between stars in the solar neighborhood, distances measured in light years. The structure of these clusters has long been a puzzle to astronomers. As expressed by E. Findlay Freundlich in a publication of the Royal Astronomical Society, quote, "The main problem presented by the globular star clusters is their very existence as finite systems. As this author brings out, some force must oppose gravitation in order to account for the observed structure, but no force adequate for the purpose has ever been identified. The only possibilities that have ever been suggested are rotation or high-speed motions and frequent collisions as in a gas aggregate. But there is no evidence of any such motions on a scale adequate to counterbalance gravitation. On the basis of what is currently known, therefore, the cluster should either collapse into one central mass or disperse. It does neither. All of the astronomical evidence indicates that these clusters are stable, long-lived objects. What has not been recognized is that the problem with respect to the globular clusters is the same problem that exists with respect to the galaxies. If gravitation is the only force to which the galaxies are subject, they too should collapse into one central mass. As Einstein expressed it, quote, "The stellar universe ought to be a finite island in the infinite ocean of space." The observed situation calls for some kind of an antagonist to gravitation, and the Big Bang has been invented for this purpose. However, the similarity of the galactic situation and that of the globular clusters makes it an almost foregone conclusion that the same antagonist is involved in both cases. The Big Bang is therefore ruled out, as it obviously cannot explain the globular cluster structure, not even if it is supplemented with a host of little bangs. But the outward progression of the natural reference system does supply just what is needed. Each star of the cluster is outside the gravitational limits of its neighbors, and it therefore moves away from them in the same manner in which the distant galaxies recede from each other. But the outward motion of the cluster stars is limited by the gravitational effect of the cluster as a whole. And the net result is that each star takes up an equilibrium position in a stable structure. So far, I have discussed three important physical problems that are resolved by this one principle that comes directly out of the basic postulate of the reciprocal system. This is by no means the full extent of the applicability of that principle. In fact, the outward progression of the natural reference system plays a significant part in every physical field. However, this discussion will have to be limited to fundamentals. So I will return to the basic concept and point out another of its direct consequences. This second unique feature of the universe of motion is that the fundamental motion is scalar. The unit of motion is simply a magnitude, 1 unit of space per 1 unit of time. Scalar motion is given very little consideration in conventional physics because it plays very little part in the phenomena with which present-day science deals. The motion of the spots on the surface of the expanding balloon that I used earlier for purposes of analogy is scalar, but physicists are not much interested in expanding balloons. The finding that the basic motion of the universe is scalar changes this situation dramatically. The properties of scalar motion now become extremely important. Scalar motion, like other scalar magnitudes, may be either positive or negative. A positive scalar motion, an increasing magnitude, appears in a fixed spatial reference system as an outward motion. A negative scalar motion, a decreasing magnitude, appears as an inward motion. I am often told that attributing one direction, such as inward or outward, to a scalar quantity is contradictory, since it is a scalar quantity by definition, has no direction. But we do not deal with the scalar quantity itself. We deal with the representation of that quantity in a fixed spatial reference system, and that representation is necessarily directional. In fact, it has two directions, a scalar direction, inward or outward, and a vectorial direction, such as northeast or southwest. These directions are independent of each other. A photon moving east from a source is moving outward. A photon moving west from the same source is likewise moving outward. One of the significant consequences of this independence of the directions is that a motion may have a continually changing vectorial direction. That is, it may be a rotation, while it still retains the same inward or outward scalar direction. For reasons which are explained in my book, Nothing But Motion, scalar rotation can take place only in the inward direction, where a complex motion has several rotational components. One or more of the minor components may have the outward direction, but the net total rotation must be inward. A rotating scalar unit is therefore moving inward in the manner of a spot on the surface of a contracting balloon. In a spatial reference system, This scalar rotation resembles a rolling motion. Okay, I think that's about it for today. I think we've got about 2 more days to go here on this, but we will stop there and take over tomorrow while he's getting into the rotating scalar motion that only can go inward and therefore moving inward in the manner of spot on the contracting balloon. And so we'll identify that and go on from there when we resume tomorrow. Thank you for tuning in today and have a great day.